So, good morning students. I am with a new session of this engineering chemistry topics. So, I will be talking about the introduction, that is the reference electrodes. Then I will be talking about the important reference electrode, that is the She electrode, and I will be talking how the She is going to act as a anode or a cathode with respect to zinc, and similarly how She is going to act as a anode or a cathode with respect to copper, and finally I will be talking about the limitation of the She electrode. So, what is the aim of this video lecture? So, with this video lecture we can determine the electrode potential of any unknown electrode or any metallic strip. Okay? So, the metallic strip has to be in equilibrium with its metal ions. And what is the outcome of this video lecture? From this video lecture we are going to understand how She can act as a standard reference electrode. Okay? So, let us start with the first topic, that is the introduction. The most important point regarding the She electrode is it has got zero potential. Okay? So, we are not talking about the gender She, we are talking about the standard hydrogen electrode, that is the She electrode, which is the reference electrode, and this reference electrode has to be used with respect to any other electrode, unknown electrode, or any other metallic strip whose electrode potential at standard conditions have to be calculated. So, we know that electrode potential is nothing but the potential difference between the metal and its ions. So, if at all we talk about actually the oxidation potential, so oxidation potential is a tendency of any unknown electrode to lose electron. If at all we talk about the reduction potential, that is the tendency of any metal to accept electrons. So, if at all actually we talk about the simple galvanic cell, so it has got two electrodes, the anode and the cathode. So, one electrode has got the tendency to lose electrons, which is designated as negative, and the other electrode has got the tendency to accept electrons, which has been designated as positive. And if at all we want to find out the electrode potential of any unknown electrode, it has to be measured at a standard condition. So, the standard condition actually is 25 degrees centigrade, 1 atmosphere, and 1 molar per decimeter cube. Whenever we are trying to find out the electrode potential of any unknown electrode at these standard conditions of 298 Kelvin, 1 molar per decimeter cube, and 1 atmosphere pressure, then we are trying to talk about the standard electrode potential. So, we are going to use this She electrode as a reference electrode to determine the electrode potential of any unknown electrode at these standard conditions. Before, I would like to tell about what are these reference electrodes. We know that to construct a voltaic cell, we should have two half cell. The one half cell where oxidation occurs and the other half cell where reduction occurs. So, it is very important that to construct a voltaic cell, we should have two half cells. If at all we are trying to determine the electrode potential of any unknown electrode, this unknown electrode is called as the working electrode, and to determine the electrode potential of this working electrode, which is an unknown electrode, it has to be connected to an electrode X, and this electrode X to be a reference electrode, because determining the electrode potential of a single electrode is impossible. To determine the electrode potential of any unknown electrode, we definitely require any reference electrode. We have got a working electrode, and this working electrode has to be connected to a reference electrode, and this reference electrode should have some fixed values whose electrode potential is known to us. Once we connect the working electrode to a reference electrode by using voltmeter, we can find out the cell potential of the unknown electrode or the working electrode at standard conditions. And how is that we are going to find out? So, simple calculation is the electrode potential of a working electrode minus electrode potential of a reference electrode. Now, we should understand there are some basic requirements for a reference electrode. To measure the potential of any of the working electrode, we require the reference electrode. So, following are the parameters for a reference electrode. The reference electrode should have a stable and well defined electrochemical potential, and this potential change with the temperature. So, ideally speaking, any reference electrode should have fixed value of electrode potential. And second important requirement is a good reference electrode is non-polarizable. That means its potential value should not vary with the time, and the value should be remain stable enough on passage of even a small amount of current. Okay. So, these are the two important parameters required for a reference electrode. So, what are the basic requirements? It should have a fixed potential value whose value will not change with the time, and even with the passage of a small amount of current, the electrode should be non-polarizable. We have got two categories of reference electrode. The primary reference electrode, that is the She electrode, which we are going to take up this in this video lecture, and the second reference electrode is called as the calomel electrode. This calomel electrode we are going to take up in the next session. Let us try to understand the She electrode, that is the standard hydrogen electrode. For a She electrode, the setup actually is basically made of a platinum foil, and this platinum foil is coated with the platinum powder. So, it is a basically platinized platinum foil, and it is on the surface of this platinum foil coated with a fine powder of platinum, the redox reaction occurs. And this platinum foil is connected to a platinum wire, and the whole setup is covered in a glass jar. And this setup is immersed in 1 molar solution of H plus ions. And we have got an inlet where the hydrogen gas is allowed to purge in, and there is an outlet for excess of hydrogen gas to be released out. This hydrogen gas is in equilibrium with the H plus ions maintained at 1 molar concentration, and the pressure of the hydrogen gas is 1 atmosphere. So, this 1 atmospheric pressure hydrogen gas is in equilibrium with the 1 molar H plus ions. Now, let us try to understand how this She electrode can act as an anode or can act as a cathode when it is connected to a working electrode. So, this is actually a She electrode where we have got a hydrogen gas actually to be passed in through this inlet, and you can see here this is the platinum wire which will connect to the platinum foil, and it is on the surface of this platinum foil the following reactions occur. Since we are trying to purge hydrogen gas, so this hydrogen gas, if at all it undergoes oxidation, so it is going to release 2 H plus ions plus 2 electrons. This we can see from here. So, we have got a hydrogen gas, and this hydrogen gas on undergoing oxidation will release H plus ions. And if at all this She electrode can do the reverse reaction where the H plus ions on taking up actually 2 electrons will convert to hydrogen gas, then this process we call it as reduction. So we have got actually two chemical reactions occurring at the surface of the platinum foil. One is the oxidation reactions where hydrogen gas is converted to H plus ions releasing 2 electrons, or the other way around is that on the surface of this platinum foil we can have the reduction reactions where the H plus ions will take up the 2 electrons to release the hydrogen gas. We should make sure that the whole setup has to be constantly maintained at a standard atmospheric pressure of 1 atmosphere and 1 molar concentration at 25 degrees centigrade. I can say that the 2 H plus ions in the aqueous will take up the 2 electrons to form H2 gas, or the H2 gas can undergo oxidation releasing H plus ions with 2 electrons. So these are the two half cell reactions actually which occur at the surface of the platinum foil. Let us try to understand. So internationally it has been accepted that the She electrode has been arbitrarily assigned a potential of 0.00 volts. It is due to the fact that this 0.00 volts will be as a standard reference when we are trying to find out the electrode potential of any unknown electrode if we are using the She electrode as a reference electrode. This actually 0.00 volts will be a standard reference value to determine the electrode potential of any of the unknown electrode or any of the metallic strip which is in equilibrium with its metal ions. This has to be memorized by any of the student. For a She electrode, the electrode potential at standard condition is 0.00 volts. Let us try to understand the working behavior of a She electrode. So this is the She electrode which has got a platinum wire, a platinum electrode covered with a platinum powder, and the whole setup is maintained at 1 molar H plus ion concentration, and we have got an outlet for the excess of hydrogen gas. So this hydrogen gas is bubbled to this system at 1 atmosphere. So whenever we are having any reactions, the reactions occurs at the surface of this platinum foil, and there are two categories of reactions: the oxidation reactions or the reduction reactions. In the oxidation reaction, we can see the H2 gas is converted to H plus ions. So the H2 gas will convert to H plus ions releasing 2 electrons. So we can write this reaction as a reversible reaction where the oxidation reaction is the release of 2 electrons, or the reduction reaction is the liberation of the hydrogen gas. It is at the surface of this platinum foil we can have the redox reaction. This She electrode has been given a value of 0.00 volts. This She electrode has to be used as a reference electrode with any of the electrode whose potential can be measured by this voltameter. This She electrode is a very important reference electrode for most of the calculation of electrode potential. Here let us try to understand what is the electrochemical reactions of She with respect to any other metal. Let us try to understand. Now in the electrochemical series we know that this redox reaction of H plus ions converting to H2 gas has been given 0. The metals which are placed above hydrogen, they are electropositive elements, and these electropositive elements they act as anode. When they act as anode, the She electrode will act as cathode. When these electropositive elements they are acting as anode, they liberate electrons. I can say that these electrons are taken by the other half cell, that is the She electrode. So at the She electrode, the electrons liberated by these actually electropositive elements they are taken by the She electrode and they convert the H plus ions to hydrogen gas. And how is that actually? We can say that the She electrode is acting as a cathode and the electropositive elements they are acting as a anode by simple deflection of the voltameter. We can see here this voltameter is deflecting towards the right side. That means this metal is acting as an anode and the electrons are flowing from the external surface and they are reaching at the cathodic compartment where the cathodic compartment is the She electrode. And this She electrode is trying to catalyze the reduction reactions by accepting the electrons from the other half cell. And obviously we also require the salt bridge to maintain the electric neutrality. And we have got elements which are placed below hydrogen, and these are those elements which will act as cathode with reference to She. The elements which are placed above hydrogen will act as anode, and the elements which are placed below hydrogen, they act as cathode. When these elements are acting as a cathode, now the She electrode will act as an anode. In such case, we can see that the deflection of the voltameter will be towards that sign where the She electrode is trying to release electrons and the other electrode is trying to accept electrons. Let us try to understand She versus zinc. And we should know that zinc is occupying a higher position in the electrochemical series, much higher than the hydrogen. We have got a situation where zinc is dipped in zinc sulfate, and we have got the She electrode maintained at 1 atmosphere or 101 kilopascals. Now, as we know that in the electrochemical series, zinc is having a position higher above than hydrogen. Now, in such situation, the zinc will act as anode. We should know that in an electrochemical cell, anode is designated as minus sign. And this anode will release electrons and the deflection of the voltameter will be towards that side, showing that the electrons are moving from the anodic compartment to the cathodic compartment. Now, at the cathodic compartment, the H plus ions, they take up the 2 electrons released from the anodic compartment and convert to hydrogen gas. So, we have got an anodic reaction where zinc solid is converted to zinc plus 2 and the oxygen state is increased from 0 to plus 2, releasing 2 electrons. And we have got the other reaction where H plus ions will take up the 2 electrons to release hydrogen gas. We should be very sure that the concentration of Zn plus 2 ions will be 1 molar per decimeter cube, so as the concentration of the H plus ions, and the whole setup has to be maintained at 298 Kelvin, that is 25 degrees centigrade with 1 atmospheric pressure of hydrogen gas. Whenever the She is connected to zinc metallic strip, the She electrode will act as a cathode. I can say that this is the following cell reaction where Zn is undergoing oxidation to form Zn plus 2 and H plus ions in the aqueous medium, okay, they are converted to H2 gas. So, this is the way the reduction reaction can be written. So, we have got a redox reaction whenever the She is connected to zinc, where She is acting as a cathode and zinc is acting as a anode. Let us try to understand how we are getting the value as 0.76. Since we are trying to use a voltameter, this voltameter will give the value of 0.76. So, we know from our previous experience that whenever we want to find out the EMF of a cell, EMF is nothing but E cathode minus E anode, or I can say that the electrode potential the electrode potential at the left half cell with the standard conditions. Since in this case the She electrode is acting as a cathode whose value is arbitrarily fixed as 0.00 volts, and now the voltmeter is giving a voltage of 0.76. The resultant potential can be written as minus 0.76 volts. This is what we are trying to see in the electrochemical series. The standard reduction potential of zinc is minus 0.76. That means zinc has a more tendency to undergo oxidation and less tendency to undergo reduction. So it has got less tendency to undergo reduction, that's why minus sign. So this is the overall reaction where we have got the two half cell reactions. Okay, so the reduction half cell reaction and the oxidation half cell reaction, and this is the overall reaction. Okay, for zinc connected to She electrode. This is very obvious from the electrochemical series where zinc has got a minus 0.76. So for any metals which are placed above the hydrogen electrode, they have been given a minus sign. Okay, minus refers to the tendency to undergo, minus refers to the tendency to undergo oxidation and less tendency to undergo reduction. Let us try to understand how She electrode will behave with respect to copper. We should know that copper is placed below hydrogen in the electrochemical series. So whenever I have a copper dipped in copper sulfate solution and which is connected to She electrode, now the voltmeter actually will give the deflection actually to the right side, showing that copper has got more tendency to accept electrons. In such case, the She electrode is the one actually which is acting as a anodic half cell, where the H2 gas is converted to H plus ions, releasing 2 electrons. And these 2 electrons, they are reaching to the other compartment through the external circuit. We should know that in the previous case, the copper plus 2 ions is maintained at 1 molar per decimeter cube, and the H plus ions is also maintained at 1 molar per decimeter cube. This conditions to be maintained actually throughout the process, where the hydrogen gas is at 1 atmosphere or 101 kilopascal at 298 Kelvin. So this is the following reaction where the copper plus 2 ions, they get reduced to copper solid. So the copper plus 2 ions in the medium, they take up the electrons from the other half cell and they get deposited at the copper metallic strip. On the other hand, the hydrogen gas is getting oxidized to H plus ions, releasing 2 electrons. Whenever we have got a She electrode connected to copper, the She electrode will act as an anode and the copper electrode will act as a cathode. And we are also interested actually what is the electrode potential measurement when She electrode is connected to copper. Is it plus 0.337 or minus 0.337? We should know that EMF is equal to E cathode at standard condition minus E anode, or similarly electrode potential of the half cell which is at the right side minus electrode potential of the half cell which is placed at the left side. Now since the She electrode is connected to copper and copper is acting as a half cell which is accepting electrons, so the cathodic reactions occurs at the half cell where copper is dipped in copper sulfate, and the anode reactions occurs at the other terminal. I can say that the voltammeter is giving a value of 0.37. E cathode, so 0.337 minus 0. Since we are telling that the reference electrode she has got a value of 0.00 volts. So I can say that the EMF is plus 0.337, indicating that copper has got more tendency to accept electrons and less tendency to undergo oxidation. This copper metallic strip has got more tendency to accept electrons to convert from copper plus 2 to copper solid rather than the inverse process. So this can be easily what we call been seen in the electrochemical series, where along with copper even other metals have got a plus value, which clearly indicates that when these metals are connected to She electrode, the She will act as a anode, and the metals which are placed below that they act as a cathode. And we have got some limitations with this reference electrode, though like this with this reference electrode we can find out the electrode potential of any unknown electrode at standard conditions. It has got some few limitations. Let us see one by one the limitations of the She electrode. So it is very difficult to regulate the hydrogen gas at absolutely 1 atmospheric pressure throughout the experiment. And secondly, the hydrogen gas will keep on actually bubbling out some amount of HCl. So this will decrease the concentration of HCl. This will decrease the concentration of H plus ions. So obviously it is very difficult to maintain or regulate 1 atmospheric hydrogen pressure and also to maintain 1 molar H plus ion concentration. And moreover, this platinum foil will be poisoned by some amount of impurities. Okay, so these impurities actually are basically some kind of oxidizing agent. So in presence of actually a strong oxidizing agent, we cannot use this She electrode. Okay, so these strong oxidizing agents such as permanganate and potassium dichromate will readily affect the working condition of the She electrode, and it is also affected by mercury, arsenic and sulfur, which will affect the working nature of the She electrode. And it is not very convenient to assemble the apparatus in a short period of time. So I can say that maintaining the H2 gas at 1 atmosphere is a very difficult task, and also 1 molar H plus ions is also a very difficult task. So these are the two important actually limitations which are observed with the She electrode. So it is very important that we are supposed to depend on some other electrode which is called as the secondary reference electrode. We are going to talk about the secondary reference electrode, that is the calomel electrode, in the next session. And finally, it is difficult to get pure dry hydrogen gas, okay, which is very ideal for the platinum to sustain. So this platinum foil actually will be oxidized if at all actually we try to use the impure hydrogen gas. We are actually at the end of the session, and we have concluded the following topics. So we understand what is this reference electrode all about, and this reference electrode, how it is acting as a cathode when it is connected to zinc, and how it is acting as anode when it is connected to copper metallic strip. And at the end we have taken some of the limitations of the She electrode. So this what we have come to the end of this session. So I hope that if you have got any doubts, actually you are free to ask me by dropping an email or by WhatsApp to my number. So thanks for your kind attention. Thanks one and all.